So welcome to all. So here we are going to see heat treatment topic of engineering materials and metallurgy. So basically heat treatment consists of three basic steps. One is heating, then another one is holding, then cooling. So this is three basic steps involved in heat treatment of any material. So initially, what is in the heat treatment process? It is a combination of operations involving heating and cooling of metal or alloy in a solid steels to obtain desired conditions. So cooling plays a important role. So the rate of cooling it impact the material properties. So like machinability and ductility. So then the heat treatment process is classified into three categories. One is softening process and hardening process and surface hardening process. Softening process consists of annealing and normalizing. Hardening process consists of hardening, tempering, and surface hardening consists of carbonitrading, carburizing, nitrading, and cyaniding process. So then what is the type of heat treatment process available? So basically categorized in four categories. One is annealing and normalizing, hardening and tempering, and case hardening. So these are all comes under the heat treatment process. So based on the application we are going to see one by one. So before going to see the heat treatment process, we should know the quenching. So quenching it means the process of rapid cooling a metal by dipping into a quenching bath. So quenching mediums are air, water, oil or brine solutions. The heated steel become much harder and stronger by a rapid cooling. So what are the stages of quenching available? One is vapor jacket stage, another one is vapor transport cooling stage, and liquid cooling stage. So the main objective of heat treatment, the object of heat treatment is to make the steel suitable for some specific applications. So the shape of grains can be altered by heating the steel to a temperature, recrystallization temperature or phase change temperature, and above that of recrystallization and duration of heating and rate of cooling, it impact the properties of material. So then another first topic is annealing. What is meant by annealing? It is a process of heating the steel slightly above the critical temperature. That means 7 to 3 degrees Celsius in iron carbon equilibrium diagram, and allowing it to cool down very slowly. So in this process the material is placed in furnace itself. So what are the physical properties obtained in annealing process? The softness can be improved and strength also improved, ductility improved, and internal stresses of the material can be relieved. Then another one is full annealing. It is comes under the annealing. So heating a steel to a temperature at or near the critical point and holding for some period of time, then allowing it cool down slowly in furnace itself. It is called full annealing. The main objective of full annealing are to soften the material and to refine its crystalline structure and to relieve the stresses. So what are the materials can be full annealed? Hot work steels, forging and casting made from medium and high carbon steels need the full annealing. So this is the graphical representation of full annealing. So in the diagram is between temperature and percentage of carbon. So we see the temperature of A1 line of 7 to 7 degrees Celsius. In above 7 to 7 degrees Celsius, we initially heat the material and holding for some time, and then allow to cool down very slowly in furnace itself. These are all the full annealing process. Then another type of annealing is glass annealing. It is a controlled process of slowly cooling the glass to relieve these internal stresses. Internal stresses are developed during the manufacturing of glass. So at the time of manufacturing, the internal stresses are developed. So before going to the application, we should remove the internal stresses of the glass material In that purpose, we are doing glass annealing process. First, the glass is heated to an anneal point, then temperature at which residual stresses in a glass are reduced over a matter of minutes. Then it is slowly cooled to a room temperature. So next type is stress relief annealing. So the main purpose to remove the stresses in the material. We are going to stress relief annealing. So the large castings or welded structures tend to possess internal stresses caused mainly during their manufacture and uneven cooling. So in that process, that graphical representation is between temperature and carbon percentage. We initially heat the material or metal below the 7 to 3 or 7 to 7 degrees Celsius, then holding for some times, then allow it cool very slowly. Then next type of annealing is process annealing. So the process annealing is mainly carried out to remove the effects of cold working and soften the material. So this is also the shown in the graphical representation. The percentage of carbon and temperature. Initially we heat the metal into below the recrystallization temperature 7 to 3 degrees Celsius, then holding for some time, then allow it cool very slowly. Then second last type of annealing is spheroidal annealing. In the type of annealing is carried out in a hyperductile steels, consists of perlite and cementite structure. The cementite forms a brittle network around the perlite, so this presents difficulty in machining the hypoductile steels. So in this annealing, to improve the machinability of annealed hyperductile steels, periodized annealing is applied. So in the graphical representation, more than the material consists of 0.8 percentage of carbon and 2 percentage of carbon is called hyperductile steels. So in the steel, we initially heat the hyperductile steels below the recrystallization temperature, then holding for some time, then allow it cool very slowly. So another type is heat treatment process is normalizing. So normalizing, why we go for normalizing? To achieve high hardness and strength. So the metal is heated above the upper critical temperature. At this temperature, the structure is converted into austenite and removed from the furnace. Then it is cooled under the natural convection at a controlled room temperature. The main difference between annealing and normalizing is cooling process. In annealing, the material is cooled in furnace itself. In normalizing, the metal is taken in the furnace and placed in a normal atmospheric temperature. So in this process, the atmospheric air is going to play a major role. So due to the atmospheric temperature, the material is cooled down very slowly. So based on the slow cooling, the defined structure is obtained. So in the graphical representation, it is also placed in a temperature versus carbon percentage. So in the diagram, and normalizing annealing temperature is above the upper critical temperature of 7 to 3 degrees Celsius. It is shown in the diagram. So this is the difference between annealing and normalizing. So in normalizing, we obtain the high hardness and strength compared to the annealing. So the next one is hardening of steels. So what is meant by hardening? It is a process of the heating the steel above or below the critical temperature for a particular period of and allowed to cool by oil or water rapidly. So before we in above topics, we see the cooling medium is air and furnace itself. Then here the cooling medium is oil or water. So the rate of cooling is rapidly decreased. Due to the rapid cooling, we obtain hot structure. So in the graphical representation, the temperature is as carbon percentage. So in that hardening process, we heat the material above the 7 to 3 degrees Celsius of upper critical temperature, then holding for some time and cool in a oil or water. So the temperature is rapidly reduced, so we obtain the hot structure. So this tempering stone is tempering is mainly we obtain the martensite structure. So in this structure having the brittle property and also it has internal stresses. For minimizing the hardness and removing the internal stress, we heat the metal near to the upper critical temperature once again and let it for some time, then cool by air. So we apply this process, we remove the internal stress and also the brittle property of the material.